Actually, this topic is about computer vision, but we also use machine learning. We also use deep learning to implement in this work, and we focus on the unsupervised based approach for doing the anomaly detection for the surveillance videos. So from this talk, I hope you get some knowledge from this talk, and maybe you can, if you are interested in this kind of topic of research areas, you can also contact me as well. I will give you an email address. So if anyone interested in this research, so please.
Excuse me, ma'am. Sorry to interrupt you, but we can see your screen, but it's blank.
Oh, really?
Yeah, yes, ma'am.
Okay, let me check.
We could see the Chrome open, but your presentation was not there.
Yeah, we can see your window, but it's black.
Oh,
Total.
okay, I see. Let me try again. Okay, how about this? Can you see the slide?
Yes, ma'am, it's visible now.
Okay. Yeah. So here's the talk that we will go through in this 1 hour. Okay, so let me introduce myself a little bit. So my name is Tita Pongkanokratana. I'm the lecturer in Applied Computer Science program in Department of Mathematics, Faculty of Science, King Mongkut University of Technology, Thonburi. I am also the certified IEEE Volunteer Leadership Trainer and also IEEE Thailand Section Secretary and IEEE MGA Award Committee as well. So a little bit of my background, I have graduated my bachelor degree in media technology, first class honor and gold medal. And then I got a scholarship to continue my master and PhD. So I continue my journey in Chulalongkorn University in electrical engineering. And then in my PhD journey, I also had a collaboration in research with Professor Nicu Sebe in University of Trento in Italy. Okay, so yeah, this is just a brief introduction of my background. So for this topic, okay, so I would like to discuss about anomaly detection. So first of all, we need to understand what is anomaly, right? So anomaly is something that deviates from what is standard, normal, or expected. Or we can say that it is different from the majority pattern. So if you consider about the scene in the video, and it can be like objects or events that is different from the majority patterns in that scene. Okay, so when we focus on video, we can consider about video anomaly detection, or we can call this one as VAD. So VAD here is the identification of items, events, or observations which do not conform to an expected pattern or other items in a video. So what we would like to do in detecting abnormal events here, we usually implement with the surveillance system. So we gather the data from the CCTV cameras, and then we analyze the situations from those scenes. So for example, if you have the CCTV cameras and then you get the video frames, then you extract those frames. And for example, in this picture, this is actually the dataset from UCSD dataset. So the abnormal event here in this scene is this vehicle. Okay, so usually like people just walking normally, and it is formed as the crowded scene. And then there is this vehicle coming through the scene. So we would like to detect this vehicle as the abnormal event. So just to show you that this is like the different patterns from the majority patterns in the scene. So what we do is that we try to detect and also localize the pixels of these, abnormal events in the scene. And we expect it to work in the real time, because usually when we do this, abnormal event detection, this kind of system is it is suitable for working in the real time, because it works for the surveillance kind of security system. Okay, so there is a lot of challenges in VAD. Okay, so first of all is about the scene. So usually this problem is like surrounded or occurred in the crowded scenarios. So this means that it has higher complexity. It has a lot of occlusions and clutter scenes than the uncrowded scenarios. And for the data set, this is also another challenge, because we have a lot of normal data for the training, but we don't have enough of abnormal training samples. So the lack of abnormal training samples in the data set here leads to insufficient training information, and also the difficulty of how to design the good classifier for indicating abnormal events. And because of the lack of abnormal training samples here, it means that it is also difficult to to take all of the abnormal training samples to the model, because in real world situation we do not know what abnormal events will occur. Okay, so we cannot just take the sample that we have only, and then we cannot just label it like that, because in real world situation it is unpredictable. So yeah, so that's why we focus on the unsupervised learning based approach, because we would like to just take the normal events to the training, so that in the testing, when we feed all of the inputs to the system, then we can find a difference between the trained data and the unseen data. Okay, so as you can see here from the picture and at the right hand side, so this one you can see that it is the crowded scene, and we can see it clearly that this vehicle here is the abnormal event, and we can detect this one. Okay, but for this one, actually this person riding bicycle, and it is also considered as abnormal event as well, but because of the scene is crowded, and we don't have enough samples of the abnormal event, so the model just misunderstand this one as the normal event. And for another example, so this one here, you can see that this person ride a bicycle, so the model knows that this is abnormal event. But for this vehicle here, because of the appearance of the vehicle, is some part of this vehicle is missing, so that's why the model cannot detect and localize that this is abnormal event. Okay, so this is also the challenges in this VAD research area. And another one that is very important is about object localization. So most works achieve high accuracy only on anomaly detection in a frame level. Okay, so what we would like to do is we would like to enhance the accuracy of the object localization at the pixel level, because most work just when they focus on the frame level, so the accuracy of the pixel level is much lower. And if the accuracy of the localization of the object is lower at the pixel level, it means that we cannot know like the exact location of that abnormal event in the scene. Okay, so this happens from the following reasons. So the first reason is that the full frame is fed into the model without prior knowledge on the objects. So this means that the model does not have sufficient features of the objects of interest for for when you do the deep learning. So you need to feed enough information, enough data to the model. Okay. And for the second reason is that the patch extraction here is not effective in collecting comprehensive features of the object. So with these reasons here, it makes the model to have a difficult time in learning the mapping from the appearance to the temporal information of the objects. And this results in misdetection and also false detection of the abnormal objects. And when we face those challenges, another challenge, and it is also the outcome of the previous challenges, is about false positive anomaly detection. So with this one, it decreases the accuracy and reliability of the system. For example, it decreases AUC and also pixel accuracy. And so as you can see from the picture over here, this two over here is the abnormal events, okay? But you can see that there is some pixels that is, shown as the detected over here overall in the scene, okay? And so this one, it makes the system to incorrectly detect regular events as abnormal ones. So we try to reduce the false positive anomaly detection. We try to increase the true positive. Okay, so this would make the system to work better. Okay, so how to overcome these challenges? We need to develop an intelligent anomaly detection system for surveillance videos. So we need to consider about spatial and temporal branches, and we call this as spatial temporal information. Okay, so for spatial branch, we need to consider about the appearance of the object in the exact frame. Okay, but for temporal branch, we consider about motion of the object between frames. So with these two information, we would get like a comprehensive features for the model to learn. And another thing is that we need to do the learning as the unsupervised based approach. As I mentioned earlier, because we could not just take off the abnormal events and then label it, because we could not apply such method like that in the real world situation. So instead, we take all of the normal events and then we train only those normal events. Okay, so the model can differentiate the unknown event from the learned normal events in the testing. Okay, so this is how we do in the in this work. And also most of the research works also consider about the spatial temporal information to help in gather comprehensive features for the model as well. And this is some of the background and literature review. So here I would like to show you like the overall, the big picture of the literature review in this work. So mainly you have the raw input data, and then you would like to do some feature extraction. And actually this part is also very important. And then when you get the important feature, and then you feed this feature into anomaly detector, then this detector can classify whether it is normal or anomalous events. So in the part of feature extraction, it can be divided into spatial features and also temporal features. In spatial features, it can be traditional approaches, for example, like HOG, SIF or SURF, or you can also consider the convolutional neural network as well. And for temporal features, the most popular one is the optical flow, and then some people use trajectory. Okay. For the anomaly detector, it can be divided into classifier and also neural network. For the classifier, there's a lot of a lot of classifier that used in this research. For example, some people use naive Bayes or even K nearest neighbor and SVM. Or you can also consider about neural network. So usually recent work focus on neural network. So it depends on their data and also their implementation. But the most popular one is the CNN, autoencoder, and also generative adversarial networks. So in my work here, I use GANs, as I will discuss further in the next slide. But here, just would like to show you that there's a lot of possibility approaches for this kind of research as well. So for the spatial feature information, so this slide here just would like to show you the difference between traditional or handcrafted feature versus the CNN approach. So for the traditional approach, you can see that like you have the input image here, and then you do the handcrafted feature extraction, and then you would get the feature, and then you feed into the trainable classifier. Okay, and then for the CNN approach, you can see that you have the feature extractor, but it is extracted the feature automatically. So it has like the low level feature, the mid level feature, and the high level feature. And then when you get those feature, it would fit into the trainable classifier. Okay, so this is the difference between the traditional and the CNN approaches. And here I would like to show you the actually is the result from my experiment. So at that time, would like to test whether which technique performs the best for the temporal feature information. Okay, so here is the optical flow methods, and I tested on CPU. Okay, and here I have feedback, I have a theory for wrapping, PCA flow, and dense inverse search. So I would like to show you the short video clips here. So you can see that like for the feedback here, it is quite fast. Okay, so it reaches at 94 frame per second, but you can see that it has a lot of noises like all over the frames. And because I focus on the shape of the object, and I would like to get the full appearance of the object, so this one actually give me the full appearance, but you can see that the shape is a little bit rough. Okay, and for a theory for wrapping, so this one is quite slow. So actually, it is slowest like when compared with the other three techniques. But the noise is lesser than the feedback. Okay, but the objects still have some distortion. So it means that we would lose some part of the object. For the PCA flow over here, it is not that fast as feedback, and has some noise, but we would get like a very sharp shape of the object. Okay, and for the last one, this is dense inverse search. So this one we get like around 81 frame per second, which is quite fast. And if you see from the clip here, you can see that we have like the full appearance of the object from this method. Okay, so it covers full object, and the shape of the object is quite smooth. So it means that we get less noise from this method. Okay, so in this work, I choose dense inverse search as the optical flow in order to do the temporal feature information extraction. Okay. And yeah, so another important technique is the neural network. So in this work, we use generative adversarial network, or GAN. So GAN is actually proposed by Goodfellow, like I think around like 2014, and it is very popular since then. Okay, the main concept of GAN is that GAN GAN actually is the generative model, and it consists of two models. Okay, so it has a generator and the discriminator. Okay, so GAN actually learn a mapping from the random noise vector C to output image. So we can just define GAN like this. And the target of GAN is to generate the fake sample as the real sample. So we have the real sample. For example, this one we represent it as the P data, and it is labeled as 1. We also have the fake sample, which is labeled as 0. Okay, so the thing is that GAN, these two networks of GAN try to, like fight against each other, because the duty of the generator is to generate the fake image, and the generator also need to fool the discriminator that the output from the generator is the real one. Meanwhile, the discriminator tries to discriminate whether the output of the generator is the real one or the fake one, like that. So this is how GANs work. And based on that, so this is my work. Like the first version, because after this journal, so I have continued, like, improve the accuracy and improve the like reduce the false positive. Okay, so this is like the first version. So this one is unsupervised anomaly detection and localization based on deep spatial temporal translation network, or DSTN. And it is published in IEEE Access, JCR for Taiwan. So if you are interested to read this work in details, you can also go and find this paper and download it, because it's an open access. Okay. So here I would like to talk about this work first, and then I will show you like the second version, the improved version. Okay, so the first one here, the STN. So we proposed novel unsupervised deep learning architecture based on GAN, mainly to transform information from the spatial to the temporal domain. We would like to address the anomaly detection and also localization tasks in crowded scene for surveillance videos. We also proposed the fusion of the background removal frame and a real dense optical flow frame to eliminate the noise. We also proposed concatenated spatial temporal features to combine important feature information. Okay, and the last one, we are also improve anomaly object localization at the pixel level by using edge wrapping at the final stage of this work. So here is the system overview. So from this one, you can see that we have original frame, we have background removal with the dense inverse search optical flow, and then we fuse these frames together, then we get the fused dense optical flow, which already reduce the noise from the background removal and also the dense inverse search optical flow. Okay, so we would like to have a very clear foreground objects. And then we do some patch extraction. We do the concatenation between original frame and background removal. And then we feed this concatenated frame into the generator. Then the generator will generate the generated image, which is called the generated dense optical flow. And this is in the testing flow diagram. So we feed the ground truth over here, and then we find the difference between these two frames in local pixel, and then we will get the possibility of the abnormal pixels. After that, we do the edge wrapping to finalize the final output to be only the exact abnormal events in the frame. Then we get the output. Okay, so here I would like to show you the steps of the STN. Firstly, in the feature collection. So first of all, we do the implementation on the dense inverse search optical flow. So you can see that in the dense inverse search optical flow, it has a lot of sub process, like they do the patch correspondences, also multi-scale aggregation and variational refinement. And then in the fuse dense optical flow here, so we do the fuse dense optical flow of these two frames, and then we would get like a very clear foreground objects and the clear shape of the object as well. So for the patch extraction here, we implement this one because it allows the model to learn the pattern of local pixels in the scene. So it helps us to achieve better feature collection performance than extracting the features directly from the full image frame. Okay, so this is how we define the patch extraction. And then we do the data preparation. Okay, so we do the concatenate the patches of these two frames to put into the generator. So you can see from the figure over here that this is the input of the model, and then we feed into the generator network over here, and then we get the output as the temporal representation. Okay, because our target is the temporal representation, so mainly the input here is the spatial representation and the target is the temporal representation. Okay, and then here is the generative adversarial network. So in the GANs over here, we have the generator, and we apply unit architecture, which consists of encoder and decoder, and we also apply skip connection or residual connection as well. So the advantages of this one is to improve the performance of the image transformation, also allow us to use smaller networks, which is easier to optimize as well. And then the next one is the discriminator, or we can call it as patch-GAN. So patch-GAN here performs as a binary classification. So the fake one is labeled as 0, the real one is labeled as 1. And this technique helps to fasten the learning due to the fewer parameters of the patch-GAN. It also helps in the, to apply in the arbitrarily large images as well. And for the objective functions and optimization, so the objective functions, we have GAN loss and L1 loss. So the GAN loss here, it is it consists of the loss of the discriminator and also the generator. So here we try to optimize the loss of the generator, and we use dropout instead in this case. And for the L1 loss, we have the loss of the generator over here. So Y here is the target image, which is our off fuse, and X here is the input data to the generator, or we can call spatial representations data. And Z here is the Gaussian noise, as I mentioned that we use dropout. And for the optimization here, we would get like the final optimization equation like this, and we use a DAM optimizer with this learning rate and also these momentum parameters. So for the final stage, in order to detect the anomaly, so we do the differentiation. So we find the difference between these two frames, and we would like to identify whether the scene consists the abnormal events or not. So we do the local subtraction. So if it is greater than 0, so it shows that the possible abnormal events is occurred in the scene. Okay, and then we do the normalization after that. And as the final stage before we get like the final output of the anomaly event in the scene, so we do the edge wrapping, because as I mentioned that after we do the local pixel differentiation, we would get like the possibility of the abnormal in the scene, but we still have a lot of false positive detection. So that's why we need to add some, post processing technique to help to obtain the final abnormal object localization. Okay, so this is the edge wrapping, which helps us to suppress the unimportant pixels and also helps to obtain good results in pixel level. And here we'd like to show you about the data set, the parameter settings, also evaluation criteria, and our experimental results, and some demo. Okay, so in this area, so the most popular one is UCSD dataset, UMN, and also CUHK Avenue dataset, which consists of the scenes in outdoor and indoor. Okay, so it has around like 10,000 images for like each dataset, and it is also the real world dataset as well. So it is recorded in the real scenarios, but has like different backgrounds, different events, and also camera settings. So for the parameter settings here, we use Python with and MATLAB with Keras. We also use GPU NVIDIA, and we have the reconstruction loss required to optimize until this number by using Adam optimization. And for the evaluation criteria here, we use ROCs because we need to plot like the fraction of the true positive out of the positive, also the fraction of the false positive out of the negatives as well. So this is how we evaluate. And then we also find the AUC. So for the AUC here, the higher means like the better performance, and the range of the value is from 0 to 1. Okay, so 1 here means like the perfect, like 100% correct. And usually we accept it if it is like equal or greater than 0.5. But in the recent works, usually people get around like 0.9, around that for this research. Okay, and then we also find the EER. So the lower EER represents better performance, so it's kind of the error. Okay, another evaluation criteria that we need to consider is the frame level and also pixel level evaluation. So for the frame level evaluation, it checks the performance of the abnormal event detection, whether the abnormal event is detected, and it doesn't care about the size and the location. But for the pixel level evaluation, so this one indicates the position of anomalous events, and it is triggered if the detected abnormal area overlaps more than 40% with the ground truth. So with the pixel level evaluation, it is much, challenges for evaluating the performance of the model. Okay. And here is the experimental result from the first work, the STN here. And here I would like to show you that, okay, we have some, comparison with the state of the art. And you can see that the STN here achieve um, the highest accuracy and also like the lowest EER from the pedestrian one at the frame level and pedestrian one at the pixel level. Also pedestrian to frame level as well. We also compare about the computational time during the testing. So in this comparison, you can see that this work is quite fast. Actually, it's around like 13 frame per second. But there's a lot of other works that is faster, especially like this one. They use MATLAB, so this work is very fast. But if we like compare about the accuracy, so you can see that we like the STN here achieve better accuracy. Okay. So, okay, here I would like to show you the demo of the DSTN. So you can see that we can detect and localize the abnormal events correctly. Okay, and this is the UMN scenario. So people just like walking around normally at first, and then suddenly they will just run in different ways. Yeah. So you can see that we can also detect those abnormal events, but you can see that there is some pixels that is still incorrectly detected here. Yeah. So this is CUHK Aveno. So yeah, this kid's just jumping around, and this guy just throwing some paper, some objects. So that is abnormal events. This is some static images of the results. Okay. And okay, so in this work we also um, experiment on the impact of the edge wrapping on UCSD frame level and pixel level performances. So if we didn't implement on the edge wrapping, so you can see that we have like a little bit high on the EER, but when we apply edge wrapping here, we get like a pretty good accuracy and also the lower EER as well. Okay, so here's the results compare between these two. Okay, so you can see that without edge wrapping here, it has a lot of unnecessary pixels that are detected. But for the edge wrapping here, we get very sharp and precise on the object appearance. Okay. Yeah, so this is just also another impact of the edge wrapping on the STN. So you can see that for the final output, we have a lot of precise object detection and localization. Okay. So here I would like to conclude on this work. So as you can see that we embed the additional pre and post processing approaches with the use of generative adversarial network. We also achieve like a very good object detection and localization, especially at the frame level, and also fast at detection as well. But it still has some limitations. First of all, as we use the background removal, so this technique is not that robust to the illumination changes, the noise, and also occlusion, especially if we face the complex and crowded scenes. Another thing is about the patch extraction in this work here is not good enough to provide a concise spatial object for the GAN learning. And also for the GAN model itself, it also has a problem in learning low-level features in the scene. And the edge wrapping does not guarantee that the false positive can be detected. Okay, so this is some um, limitations, and we consider that as the room for the improvement. That's why we continue to improve the work. And here's the second version, okay, of this work. So we call this one as the RSTN. So this one, a video anomaly detection using deep residual spatial temporal translation network, and it is published in Pattern Recognition Letters, JCR for Taiwan. And at the time that I published this one, it is also in Tier 1 as well. Okay, so in this work here, we propose the unsupervised DRSTN to learn only normal events without any handcrafted features. We do the end-to-end unsupervised deep versatile connection network to enhance the perceptual information of the reconstructed images from the generator. And we also use the object detector as the pre-processing process to extract only the objects of interest. We also introduced the online hard negative mining and a semantic region merging as the post-processing processes to eliminate false positive and integrate the intensity of the objects for the final anomaly output. Okay, so here is the system overview. So you can see that we still have like the main concept is the same as we still use generative adversarial network, but this time we use conditional generative adversarial network, and we have adjust some part, like we apply the object detector here. We also use online hard negative mining to to force the false positive, okay, to be the true positive, and we do the semantic region merging in order to get the final anomaly detection. Okay, but the main concept is still the same, as we would like to have the input at the spatial representation, and then we transform it into the temporal representation, and we compare between the generated temporal representation with the real temporal representation that we get from the dense inverse search optical flow and the object detection over here. Okay, so this is the overall of the testing for this work. And here is the demo of the RSTN. So in this one, you can see that we have a very good performance in detection and also localization. So actually, this work improve a lot of percentage in accuracy. For example, like in AUC for the pixel level. Okay. And yeah, so this is another example. Okay, so we have implemented with three of our data sets. So it has a UCSD data set, it has UMN, and also CUHK Awenu. Okay, so let's see. Yeah, so for this work, it provide like more comprehensive on the distinguish feature of the object than the first one. Okay. Yeah, actually, this data set is set in front of the university gate. Like people, these are students. They are walking to the study room or something, and then they're just like this kid and the guy just running around and throwing some objects. Yeah. Okay, so here's the still images for this work, the RSTN. So you can see that it correctly detects and localizes abnormal events in crowded scenes, and also fixes misdetection and false positive detection problems. Yeah, so this is from another example, UMN and also CUHK Avenue. Yeah, so for the advantage and disadvantages, so for this one, we propose the RC-GAN with the robust pre and post processing approaches. And with this work, we achieve more accurate anomaly detection than the first one. It also provides better spatial temporal translation, and also the quality of the synthesized image due to the residual units that we also apply in the RC-GAN, and also the binary cross entropy loss with logits loss in the discriminator in this work. We also obtain the good object detection and localization, especially at the pixel level, and also, of course, reduce the false positive by online hard negative mining. But for the disadvantages on this work, because the model is more complex than the first one, so it has bigger size, and it has higher number on the parameters. Also, it consumes more time than the first work as well. Yeah, so here I would like to show you like the first one and the second one, and also the other state of the art works. Okay, so here I try to, show the comparison like in a comprehensive way. So I list all the benchmark data set, UCSD pedestrian 1 at the frame and pixel level, also at the pedestrian 2 at the frame and pixel level, also CUHK, Venue, and UMN data set. So you can see that the second work over here achieve a very good in AUC and also EER results over here. Yeah. And this is some ROC plot. So the RSTN is the blue line and the STN is the red one. So you can see that the RSTN achieve a very good performance here, like outperform other state-of-the-art works. Okay. And this is to compare between these two works. Yeah. So it's better, but it still has some room for improvement, of course. So this research is very challenging, and it still has a lot of things to do in order to improve the accuracy, to reduce the false positive, and also how can you implement this work into the real world situation, which is really, really challenging. So here I would like to add some of my projects that I have implemented in Thailand, in my country. So we have implemented the system, kind of security system in Chonburi city. I don't know if any of you ever heard of Chonburi. Actually, actually, Chonburi is the province in Thailand, and there is Pattaya, Pattaya Beach. Yeah, so very famous. Yeah, so Pattaya is located in Chonburi province, and we have installed our system in Chonburi province at two intersection. Okay, so the first intersection is Chonrat Amrung, and the second one is Chalerm Thai intersection. And we install like the first intersection, we have like 4 points of CCTV cameras, and then the second one we have like 6 points. Okay, so here is like the first intersection, the Chonrat Amrung, where we go to install our system. And our system here is to detect the face, localize, and also recognize the face and also the license plate, and the abnormal events also in the system. Okay, so we have worked with the police in Chonburi and also Chanthaburi province in Thailand. And yeah, so we get the funding from the government to do this. And yeah, here is the scene. So you can see that from the first intersection, we will get like the scene from the road, and we get like the car from the road, like in front of the police station. Okay, and then for the Chalerm Thai intersection here, we have installed also on the bridge. So in this case, uh, actually this system is for detecting the criminal. Okay, so we have discussed with the police whether they use any other directions, or is there any directions that they can use to escape. Okay, so this is how we consult with the police, and also this is the result from the discussion that this can be the way that the criminal can use to escape. Okay, so this is like the road, one of the main road in the Chonburi province, and also the bridge over here. Yeah, so we also do the tracking system for arresting criminal. So as you can see that we have implemented on 2 intersections, then the system need to know that whether the criminal appear in the first camera, and then they try to escape, like they appear in another location to the second camera or to another camera, like that. So we need to be able to detect, to track, and also recognize. Okay, so in this case we have the criminal data set from the police. So if it is matches, like the face that detected from the system matches with the database, so that's the case where we can, detect and alert to the police. Okay. Yeah, so it also tells the category of the car, the name, color, year, like the model of the car as well. Yeah, and for the people, if it is matches with the database, okay, so it will show like the category of the people, the name, national ID, and also the province. Yeah. And so here I would like to show you that the system can be also extend. Okay, so this is uh, the second um, the second phase of the implementation of the system. So we plan to extend the system to the border area of Chantaburi province. So Chantaburi province is near to Cambodia, and usually criminal or suspected person, they use the natural border to escape. So we try to extend the system to the Thailand and Cambodia border. And this is also another plan. So we can also use the mobile cameras to detect the criminal faces, because if they like try to go through the border, then at the border there will be like the gate where the police can check on the people who go in and out. So they can use mobile cameras to detect the criminal faces as well. Yeah. Yes, okay. So that's the overall of the technical terms on the system, and I have shown you the first version of this work on unsupervised anomaly detection, which is called the STN. And then I show you like the second one, which is the improved version, where we use online hard negative mining, we use semantic region merging, we use conditional generative adversarial networks to help to enhance the performance of the system. And then I show you how can we apply in the real world situation. Okay, and yeah, so this is the overall. So for the DSTN here, it is embedded with a deep convolutional neural network of GAN based edge wrapping approach. And then for the RSTN, we use the RCGAN and online hard negative mining. For the DSTN here, it outperforms other state of the art in terms of accuracy and time complexity. And this one is very good for the real world application because it's quite fast. And for the second one, this one performs best regarding in the accuracy for the frame level and also pixel level evaluations, especially at the pixel level, and also provide the good running time. And yeah, so for the conclusion, so these two work actually provide effective and robust for anomaly event detection and localization in crowded scenes for the surveillance videos. Yeah, so this is some references. And if you are interested in learning more on this work, you can also find my paper. Okay, the first one in IEEE Access, the second one is in Pattern Recognition Letter, and both of the papers are open access. So you are welcome to go and maybe read more details. And actually, I am also work on other projects. I also have the project that I get the support from the government in medical and also in agriculture as well. So yeah, so if you are interested, you can also send me an email, thitapon.gan@kmutt.ac.th. and I'm really looking forward to, maybe we have some more opportunity or any collaboration in the future. Yeah. So thank you so much for giving me this opportunity to serve as the keynote speaker. And yeah, so also thank you for all the participants for your attention. Yeah, thank you very much.
Thank you, ma'am, for sharing your knowledge with us. Now, if anybody wants to ask any question, they can unmute their mic and ask.
Hello, ma'am, can you hear me?
Yes.
Thank you for sharing this great work with us. You said that it is having false positives, but whatever videos I could see, it was detecting things very accurately. And I have a little bit experience of image processing, and this work is totally new to me. I can see whether I can do it, means I can approach towards it or not. My question was about edge wrapping actually. Edge wrapping, I know what it is, but usually this anomaly detection we do for CCTV cameras, right, for surveillance mostly, and the background is mostly fixed. So
Mm-hmm.
why do we need edge wrapping, and what good does it do with our work? And any other image processing that we do before doing this anomaly detection, the work that you did.
Okay, so let me tell you on this work. Okay, so firstly, as you mentioned, that because the camera is static, right? So of course we would like to have a very, like, the distinguished feature from the moving foreground object. Okay, so that's why we try to explore a lot of techniques that can help us to get a very clear foreground object. And how can we subtract those background objects out of our way. Because as you can see from the scene, there is a lot of shadows, and like when the object is too far from the camera, so that is also another challenges, like because when the object moves close to the camera, so that's when we can get like almost like the full cover on the object. But for the object that is too far, so that is quite hard. So as I use like the background subtraction first to help, and then finally I use the edge wrapping, because actually in slide it doesn't show the results after the subtraction, but in the paper it has. So maybe you can find more on the image. But the image, it shows that there is some, even we use the background subtraction, and even we use the generator to generate the generated images already, it still has some faults from the generator, from the GAN. Yeah, because it's very hard for GAN to create the synthetic image that is closely to the ground truth of the temporal representation. Yeah, it's really hard. Like it takes me some time, yeah, to learn the model in order to generate that one. So after we get that results, we still have a lot of false positive. Yeah, which is really really frustrating because we have done a lot of techniques and it's still.
I remember that you said that the girl that was prancing around and the boy that he was throwing the papers, that was not false positive, right? You said that, was it?
Sorry.
The girl prancing around and the boy throwing paper, it was not false positive, right? I think you said it was false positive.
Which one, like
The
the.
girls, a small girl was prancing around. She was walking playfully, and there was a boy throwing papers
Oh
in
no.
one of the
uh
videos. It
there
was
is the
actually
false.
correct detection.
Yeah, there is the false positive if the, like,
Why
if
so?
if the system detects in the wrong position. Yeah, and mostly it detects like the normal objects as the abnormal objects, so that's the false positive one. Yeah, 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 yeah. So that's the case where we need to reduce those results. Because like when you see the scene, like okay, the kids just throw the objects, people just throw some objects. So that's the abnormal events. But then the model understand that some of the normal object is abnormal object. Yeah, so that's the case where occurs the false positive. Yeah, and we want to remove those pixels that occurs on the normal objects. Yeah.
It will be better to remove them. Yeah.
Yeah. So it's quite hard. Yeah, it's quite challenging.
But still, it was great. Yeah. Thank you, ma'am.
Does anybody has any question? They can unmute their mic and ask. So as we don't see any more questions, I would like to thank you, ma'am, for your session.
Thank you so much.
Can you hear me, ma'am? Hello?
Yes, I can hear you. Yeah.
Ma'am, please put on your camera. We need to take some screenshot of this session. And I would request everyone to unmute their cameras so we can take some screenshots.
Other participants, please turn on your camera so that I can take few screenshots. Okay, thank you. Thanks.
So thank you, ma'am, for this session. We would like to hear from you in future also. Thank you, ma'am.
Yeah, thank you.
Now we have our second keynote speaker, Dr. Shashank Degadwala. So I would like to introduce him. He is an accomplished academician and researcher with expertise in fields such as image processing, computer vision, information security, algorithm, and data mining. He currently serves as an head of the department and associate professor at Sigma University, Bakrol, Vadodara. With over 11 years of experience in academia, he has PhD in computer engineering and has authored several publications, including books and patents. Dr. Dekadwala has strong technical skills set with proficiency in languages like C, ASP.NET, C#, VB.NET, and Python. Along with extensive experience in various software and databases, he has guided numerous dissertations at both undergraduate and postgraduate level, contributing significantly to the research community through his publications and patents. Now, I would request Sir to start with his presentation. Over to you, Sir.
Thank you, madam. My screen is visible to you.
Yes, sir, it is visible.
Good morning, all of you. Today is my keynote speak on recent trend in image processing and computer vision. I am Dr. Shashank Degarwala, professor and head of department computer engineering Sigma University. And today's trend is totally based on the image processing and computer vision. Now, what is the difference between image processing and computer vision? Hello. There are very basic difference between image. Please mute your mic, please. Image processing and computer vision. To manipulate the image data and generate the another image, it is called as you can say image processing. And what is computer vision? To process the image data and generate the symbolic data. Uh, for example, you apply the image enhancement. It is a technique for improve the quality of the image you are using the image enhancement in the image processing, and you to find the image future, you are using the computer vision. Now, what is the difference between basic difference between image processing and computer vision? In image processing, research area within electrical engineering and signal processing, and in research area within a computer vision is computer science and artificial intelligence. Image processing focus on the syntax and low level architecture, and
Excuse me, sir. Sorry to interrupt you, but we can't see your presentations. We can only see your Gmail account. Though your screen is shared, but we can't see your presentations.
now it is visible.
Yes, sir. It is visible now.
Hello. First of all, what is the difference between image processing and computer vision? Image processing is manipulate the image data and generate the another image from one image. And what is computer vision? Computer vision is a process of image data and generate the symbolic data. It is called as a computer vision. Now, image enhancement is the example of the image processing, and image feature finding is the example of computer vision. You find the features from the image. It is totally based on the computer vision, and if you improve the quality of the image, you are using the image enhancement. Now, these are the very basic idea about the image processing and computer vision. If you use the research area within electrical engineering and signal processing, image processing are used. And if you are using the research area within the computer science and artificial intelligence, you are using the computer vision. Focus on syntax and low level architecture, and computer vision focus on semantic, symbolic, and geometric description. uh, if you take the image as the input and you will generate the image as the output, it is the very basic idea about the image processing. Means you convert the one image into the another image, and for in computer vision you extract the feature from the image. For example, how to extract the feature? You are taking the image as the input and you find the measurement and the description. For example, you are taking the image as the input and you generate the chair, spaces, and cars. Means these are the, you can detect the object and you give the description. Okay, this is the chair, this is the face, this is the car, like this. This is called as a computer vision. Now, recent trend in image processing. Now, for example, for for Aadhaar card or any government office, you go to the, you are doing the digital signature. Means digital signature verification based on your previous sign. Your new you based on your previous sign, you how to match the signature verification. This is the example of the image processing. Now, image debugging. For example, you this is the blood image, and based on the blood image, you want to improve you want to improve the blood, you apply the deblooding. Then this is the image. Okay, in last image you see it is a blood image, and after the applying algorithm of image processing, you improve the image. It is like this. Okay, this is called as a image deblooding. Now next is image in painting. Now it is also called as image ablosing. Now for example, you have a very old image, okay, and you apply the image processing algorithm, filtering and all these things, and you will generate the new image. Means you improve the quality of the image, you improve the you see the what is the difference between left and you have a very old image. You have a very old image, and you apply the image processing algorithm, and after the image processing algorithm you want to improve the quality, you can see it is image in painting. It is also called as the image embossing. Now texture synthesis. In texture synthesis, you have a very small image, and based on the small image you want to generate the big image. Okay, means you it is called as an image super resolution. It is called as an image super resolution. Means from the small image you generate the large image. This is called as a texture synthesis or image super resolution. This is the also topic of the image processing. Now, this paper is also published in IEEE. This is also one of my research, plant health monitoring system using image processing. Now, there are different diseases are there, and if you want to find the disease based on the particular image, you are using the image processing technique. Okay, now here you have a first browse the image, then you apply the pre-processing. There are some features are there, color features, texture features, these all are the features. Then you apply the segmentation algorithm. Then here also your conference is based on the machine learning for the classification of the particular image. Okay, this is which type of disease of the plant. You can also use the classifier, and based on the classifier you have a different classifier. Okay, decision tree, then you can say SVM. Okay, a support vector machine, then RF, random forest. These all are the algorithm you are using for the particular detection of the leaf disease. Okay, this is also one topic of leaf disease detection. Okay, now this is also one of my research. I have published totally my 100 paper is accepted in IEEE, and total 84 papers are published in IEEE conference. And you see this is all one of my paper. You see the medical image fusion using combined multi resolution and multi scaling transform. Now you have a MRI image and CT scan image. You have two image, and you apply the image fusion on both, and you are applying the DWT and discrete wavelet transform and discrete Replet transform. These all are the transform. Okay, you are applying it, and you find the proper image based on the image fusion. This is also one of topic in medical science. Now, this is also one of my research on content based. There are two types of image retrieval: content based and context based. Okay. Now, in content based, first of all, you have a query image. For example, this is the rose image. Okay. Now, apply the feature extraction. Means these are your n number of features from the particular image. Now you have a database, image database. In image database, there are lots of images are there. Now after the images, you have apply the future vector database. Means you are generating the future of the different images. Means this is the image, different images. Now you apply the similarity measurement. Now if you how to apply the similarity measurement, for similarity measurement you are using the Euclidean distance, and you are also using the Manhattan distance. These are the two distance you are using for the to find the similarity. If it is come very small, means you take this image as a retrieval image. This is the totally mathematical concept. Means you will generate the particular based on the image. You search the image on Google, you will get the image. It is called as a content base. Now in context base, if you write the any text, and based on the text you search the image, this is called as a context based image retrieval. There are two types of image retrieval: content based and context based. All of you please mind well. Now, in Corona time, in COVID-19, most of people are struggling from this COVID-19. And if you want to, find the thermal imaging, now what is the thermal imaging? If you want to find the temperature, because your head temperature is increased, then you are suffering from any viral fever or anything. Okay, to capture the thermal imaging, your face detection is very important, and based on the face detection, you capture the image, and based on the image, based on the some features, you will identify the temperature of the particular person. This is also one of my research. Now, also you can predict the fever. It is also one of my research to detect the fever. Now, OCR, OCR, there are lots of algorithms are used in OCR. And in OCR, you see, to detect the number plate. Number plate detection is one of the major topic in OCR, optical character recognition. If you have a number plate and you want to convert you take the image of number plate and you convert into the text, you are using the OCR. Now, this is also one of the topic of this is also one of my research on 3D shape reconstruction. Means you will generate the based on the 2D image, you will generate the 3D image based on the 2D image. This is the 3D image processing. Mostly people are work on the 2D image processing, but my work is based on the 3D image processing. Okay. Now, this is also one of my research on dengue infection classification using hybrid segmentation and Harlick features. Okay, here also machine learning is used. This is in right hand side confusion matrix is used. Accuracy is 86.67%, and you are using the precision and recall also. You have in our blood, WBC count is very, very important, white blood cell. Okay, and platelet count is also important, but my work is totally based on the WBC count. Now, based on the WBC count, you see, you apply the segmentation and you find out the features. Okay, then you are applying the segmentation, GLCM segmentation, then you apply the features. Okay, then you apply the SVM classifier. There are there are three types of dengue is there. Dengue, and there are different names of the dengue infection. Okay, one is low, then medial and high level dengue is also there. Nowadays dengue is also there is no medicine for the dengue, but based on the image processing of WBC image, you can detect the dengue. Okay, this is also one of my research. Now, there are the next is your blood cancer. I also work on the blood cancer. There are three types of acute lymphoblastic leukemia. Leukemia is also called as a blood cancer. There are three phases of leukemia: ALL1, ALL2, ALL3. Okay. ALL1 is very dangerous, ALL2 is low, and AL3 is more low. Means these are the different. Sorry, ALL1 is very low, ALL2 is medium, and ALL3 is very high. Means if you are suffering from ALL3, then you have a stage 4 cancer in your body. Okay, based on this, you see, I also use the WBC image for the cancer detection, and based on the cancer detection, you have to apply the feature extraction, then you apply the classification, then you apply the segmentation. Okay, these all are the techniques are used to detect the ALL cancer means leukemia cancer. Now, one of my paper is published in Springer, USO occlusion detection. Okay. Now here, you see, image behind the one image is come. Okay, object behind the one object is come. It is called as a occlusion. You based on this video, you see one one object is moving, and after the one object behind the one object, the object is detected. This is called as occlusion. This is the example of multiple object detection tracking under the occlusion detection in video sequence. This is also one of my research, and paper is published in Springer. Okay, this is also one research. This is also one of my research, multi-light source shadow detection and ablosing. You know, in day-night match, you see, if you want to capture the photo of the particular player, then there are some shadows are there. If you want to remove the shadow, first of all, you select the image, then you apply the shadow marks, and then based on the, I already told you, image in painting, based on the image ablosing, you remove the particular area of the shadow, and you will generate the in painted image. This is the also example of the image processing. Okay, up to this point, you have any doubt, please tell me.
If anybody has any doubt, they can unmute their mic and ask.
Okay. If you have any doubt, then please ask me. Okay, no problem.
So you can start. You can again restart your session.
Okay. Now, in medical application, I have also worked on many research area on medical application. I have also work on the skin cancer. Okay, and based on the skin cancer, you detect you first of all take the raw image, and then you apply all the techniques of image processing, and then you detect the skin cancer. This is also one of my medical application. Now, if you see in this, if you want to see the different my paper in IEEE, there are different papers are available on medical imaging. See here, total 84 papers are published till date of my based on my research. Okay, now if you see the newest one paper, see here, the first paper is totally based on the hair disease detection. Means if you based on the transfer learning method. Okay, second paper is totally based on the tire quality classification. Okay, you based on the deep thread transfer learning. Then hope plant disease classification. This is also one of my research. You see, there are lots of topics are there. Time pattern analysis based on the regression. Then you can see there is lots of breast cancer is also detect. by using machine learning. These all are the lots of topics. Okay, I also use YOLO V5 for it is published in Canadian Conference C. It is published in Canadian Conference, and enhancing the traffic management using YOLO V5. It is also one of my topic. Okay, I have published the paper. Okay, means these all are the there are lots of topics are there. Based on you can download it and you can research on it. If you are a student, if you are the research scholar, then you can also work on it. Now recent trends in computer vision. Now in computer vision, image recognition, first is only just pixel, no object detection. It is called as a semantic segmentation. Then classification and localization. If you detect the cat, it is a single object detection. Then object detection is dog, and cat. It is multiple object detection. And instance segmentation means you see you apply the segmentation on particular object. You are also detect the dog, and cat. This is also called as image recognition. Now, this is also one of my paper is published on colorization of black and white photographs. If you have a black and white photo, and if you want to convert into the color photo, this is also one of the topic for the research. Okay, means based on the patching, you will generate the color image. Now, image caption generation. This is also one of my research topic. Okay. Now, in this topic, you see based on the image, some text is generated. For example, man in black shirt is playing guitar. Based on the image, you will generate this text. Okay. For example, this is also one topic of image caption generation. Okay. Now, you see in second image, construction work in orange safety vest is working on a road. Then two young girls are playing with the Lego toy. Okay. Now, girl in a pink dress is jumping in the air. Like you can generate the black and white dog jumps over the bar, and young girl in a pink shirt is swinging on a swing. This is the different caption generation based on the image. Now, this is also one of my research. Social distance, social distance monitoring system. Okay, I have also worked on this. Based on the you see, this paper is published in IEEE. One of my paper is based on the safety helmet also using YOLO. YOLO is a very best algorithm to detect the object. For the YOLO is the base algorithm to detect the object. Okay. See, one of my paper is based on the COVID-19. I want to show you. It is free. You can directly download it. Directly PDF is available. Directly PDF is available. બરાબર એ ચાલે છે પ્રેઝન્ટેશન ચાલે છે. You can see COVID-19 classification. This is also directly available. Now I want to show you the one of my paper is based on the Yes. Visual social alert system using the computer vision and deep learning. This is also one of my research in based on the visual social distancing. Means the object is something near to you. Okay, then it will you see in PPT. If the object is near you, then how many persons social distance the violate the total 15% violate the social distancing you can see in this image. Okay, now next is medical application detecting the COVID-19 in X-ray image. Okay, one of my research I already show you. Okay, based on the particular image, X-ray image, you can see that okay, the COVID-19 is there on. If you see the any person report, more than 60 or 70% suffering from COVID-19 infection, you see the white color on the particular your lungs. Okay, this is also one of my research on X-ray image. Okay, in medical image. Now this is also one of my research in my LinkedIn profile. You can see the COVID-19 sorry, face mask detection. Face mask detection also means if you wear a mask, if you not wear mask or not wear properly. There are three classifications are there: wear mask properly, not wear properly, or wear. Okay, this is the three classification I have done using the face mask detection. Okay, in COVID-19 time, face mask detection is very, very important. Now, thank you. If you have any doubt or any query, you can ask me. Hello. Hello. If you have any doubt and any query, please ask me.
Thank you, sir, for your session. All the participants are requested, if they have any queries, please unmute your mic and ask. You can also type on the chat if you are not able to speak. Hello, can you hear me? Hello. If anybody is having any question, they can ask. Okay, if there are no questions, we have Dr. Shashank sir's email ID. You can ask him offline also, right? Sir, is it okay?
I write my email ID if you have any query related to. Okay, I give you my mobile number also if you have any query.
Yes, sir. There are people actually working and they have nearly started this kind of work in CS in our college. So I hope they are right now not having any questions, but as soon as they will learn, because we are recording this session also, so definitely they'll have
Okay.
some queries.
Okay.
Please, guys, note down this email ID and phone number of Shashank sir. Sir, there's a request that if you can turn on your camera, and all the other participants, please turn on your camera so that we can capture this moment with sir. Okay, just a minute. I'm just taking a picture. Yeah, Thank you. Thanks a lot.
Can I
Thank you.
leave? Can
Yes,
I
sir.
leave?
Yes, sir. Yes, sir. Thank you. Thank you for coming. Thank you for accepting our invitation.
Thank you.
We are looking forward that whenever we arrange another kind of this kind of
Okay,
conference or
okay,
any
sir.
FDP, please.
I will present. I will present. Okay.
Thank you, sir. Thanks a lot.